Hello, and welcome to Philip Brown's Computer Networking Lab. You're watching the instructional video called Frame Relay. Frame Relay is the fastest growing wide area technology, and it's being used more and more widely all over the world. It is a service that provides for shared lease lines. Frame Relay is a Layer 2 WAN protocol that uses the concept of permanent virtual circuits known as PVCs and switch virtual circuits, which is known as SVCs. A PVC is basically a predefined Layer 2 path through a service provider network that is sort of emulates a point-to-point lease line for the customer. Essentially, your router connects to a cloud of frame relay switches at the internet service provider, and the internet service provider switches your frames from one end of the cloud to the other, where it pops out to a remote router. The fun part is that all the cloud stuff is invisible to the end router for most of the part. These permanent virtual circuits and their paths through the network are defined by data link connection identifiers, also known as DLCs. The DLCs are stored up in a frame relay header. Basically what happens is this. When the router sends a frame into the frame relay cloud, it puts the DLC into the frame relay header and sends it into the frame relay switch. The frame relay switch routes the frame by doing a lookup on the DLC and passes it to another frame relay switch. The same thing repeats in the cloud until the frame is switched all the way to the other side. In this sense, that frame is switched by looking at something other than the IP header. The encapsulation frame relay command allows the router to be configured using the frame relay protocol. Both the frame relay interface DLC command and the frame relay map IP command are used to assign DLC numbers to IP addresses. The show frame map command is a very useful troubleshooting command to verify that the IP address is mapped to the DLC number. The show frame relay PVC is also useful in troubleshooting the permanent virtual circuit statistics. This is a design that we will be using in our lab. It is called a hub and spoke design. There are 3 routers, router 1, router 2, and router 3. Router 1 has a loopback of 1.1.1.1. Router 2 has a loopback of 2.2.2.2. And router 3 has a loopback of 3.3.3.3. There's a connection between router 1 and router 2 going through the frame relay cloud, and a connection going from router 1 to router 3 going through the frame relay cloud. Both router 1 and router 2 have a point-to-point IP address of 10.0.12, and router 1 and router 3 have a point-to-point connection, and router 1 and router 3 have a point-to-point IP address connection of 10.0.13. When router 1 wants to send a packet to router 2, it sends it through the frame relay with a DLC of 102. And when router 2 wants to send router 1 of a packet, it sends it through the frame relay cloud with a DLC of 201. And when router 2 wishes to send router 1 a packet, it sends it through the frame relay cloud with a DLC of 201. Similarly, When router 1 wants to send router 3 a packet, it sends it with a delta of 103, and when router 3 sends a packet, it sends it with a delta of 301. Let's take a look at the terminal server. Here we're looking at the terminal window of router 1. Let's see what networks router 1 knows about. It sees all of the routes inside of the network. That's because we use OSPF to advertise all the networks, including the loopback addresses. Now let's take a look at the running configuration. We enabled the frame relay protocol on serial interface 0. And we created a point-to-point serial interface, and we mapped the delta number 102 with the IP address of 10.0.12.2. The reason why the router knows that the delta number is 10.0.12.2 is because this is a point-to-point connection, and that is the only other point available. We're also using pseudo broadcast in order to connect with router 2. And we gave router 1 a very high priority so that it would become the designated router. Also, we did a similar feature to the serial interface going to router 3. And here is our OSPF setup. Now we're looking at the terminal server of router 2. Let's take a look at what networks it know about. It knows about all the networks also. That's because all the networks are advertised by OSPF. Now let's take a look at the running configuration. Here we set up a serial interface and configured the frame relay protocol on it. We assigned the IP address of 201 to the point-to-point IP address. And we'll use OSPF pseudo broadcast in order to connect with router 1. And we'll assign a priority of 0 so that router 2 will never become the designated router. We also configured OSPF on this router. In this video, we looked at the basics of the technology of frame relay and how it might be implemented from the client side. I hope this video has been informative, and I thank you for viewing.